Hi friends, welcome to TTV once again. Today we will be looking how to draw the drawing in model. For example, we will be taking this framing plan. Over here you could see that this is marked as C1311, etc. All these are columns. The column sizes are mentioned over here. So the grade of concrete will be M30 and grade of steel will be Fe500. Please note that we will be designing the Indian standard today. So moving on to ETABS, over here as said earlier, you'll have to take the Indian standard, that is this is pre-written over here, and custom grid spacing. So considering this, we will be having 4 meters on each side of this thing. So just entering the data over here, we'll be having 4, and this will be 8, this will be 12, and we will be adding another thing, and this will be 16. Yes, so over here the same applies. This will be 12 and this will be 16. So this is what the exact size of our grids. And now we will be moving on to this thing. Let us have 4 stories of typical story height 3.3 meter and bottom story 3.3 as well. So okay, here we go, our grid is ready now. So friends, this is our visible grid over here in ETABS. This option is called plan. Over here you can see how many number of stories we have defined, and since we will be working at story 1, let us select story 1 over here. Okay, this is story 1. Well, you can use these arrow keys to move around the stories. This is visible over here, 3, and similarly 1, etc, etc. So let us define the material properties first. Well, we very well know that the grade of concrete is M30 and grade of steel is Fe500. So let us define them first. We'll be selecting define material properties, add new material, India concrete, standard Indian, M30. Okay, this is M30. You can just select it as M30. The weight per unit volume is 25 kilonewton per meter cube, since we have reinforcement over here. The modulus of elasticity of concrete. Okay, can anyone guess what the modulus of elasticity of concrete is? Yes, you are right. It's 5000 root of CK. The FCK over here being 30, we'll be taking the square root into 5000. That is 27386.127, which is given over here in megapascals. So yes, it's right, and the values are being default. Let us give okay. So the next thing is to define the steel property. So Indian code, this will be steel, Indian, and this is, no, we'll actually take it as rebar since we're dealing with reinforcement. So HYSD Fe500. Select OK. So as said earlier, these values are to be default. And when you can verify it personally just for a check purpose and give it OK. So here it is, the material properties are defined. Yes, while defining columns, we'll have to go to define section properties, frame section. These values are all predefined in ETABS, so let us not confuse with them. So it's better that we delete it. So deleting each and every value specified over here. We can't delete this value because at least one frame section property is to be existing. So let us define a new property, that is concrete rectangular. Over here we have a list of channels here. So select concrete rectangular and we'll be defining the rectangular column over here. So let us assume, not in fact assume, that since we have the framing plan ready, let us define 200 cross 450. Going over here, let us name it as 200 cross 450 for a better understanding. This will be HYSD 500 since we're dealing with rebar. So the dimensions are to be changed correspondingly. So no modifiers are set over here. Since concrete, it has to be M30. The rebar values are predefined. Make sure that you select column over here, and these had to be a F500. These values are to be predefined. So the concrete car is to be 40 for column, and this square you are getting it by pi by 40 square. Let the confinement bar sizes be 10 so that is 79 square. Just give OK and OK. We have successfully defined this column. Similarly, we will be defining the other columns as well, that is 200 cross 750. So add new property concrete, just give it a C200 cross 750. So this will be M30 and this has got to be 750. 200. So this has got to be changed to F500 longitudinal bars, and these values remain as given earlier. And give OK. Just save the drawing. Model, let us save it over here. And now let us define the third column, that is 200 cross 1200, which is present over here. The basic thing to be noted is that what is the difference between column and wall? Anything L by D is less than or equal to 4, that is going to be column, whereas greater than that, that is going to be wall. So how to define a wall? Define section properties, wall section. Let us define a new wall, that is going to be 200. The property type is specified over here, the material being M30. Let us define it as shell thin. I'll let you know what is the difference between shell thin, thick, membrane layer in the upcoming sessions. So the thickness of this being 200 just give OK. So the wall has been successfully defined. Now you must be having the doubt of how about the length of the wall, that is 1200. While drawing the wall, I'll let you know. So important thing while drawing an ETABS, it is to be considered that you got to take a close look at what is over here. This is one story, similar story, and all story. Let us select as all stories. So while actually assigning a column at the grid here, as we see in the framing plan over here, this is going to be C1. So C1, what is that? That is 200 by 400. So draw beam column, draw beam column. This option that is selected over here. So over here in properties, we're going to select this as 200 cross 450. This is the angle, and where over here you can actually see this as horizontal. So as per our framing plan, it is vertical. So just give 90 degree over here to change it from horizontal to vertical. So just place it over here at the center. Well, in 3D you can actually see that this has come a long way till the terrace. So again, going to plan story 1, we'll be defining all the coordinates as shown over here. So to be precise, let's draw it at the grids. I guess it's not gonna come over here. It is to be noted that over here we have only 3 bays, whereas in the model it is gonna be 4. So how to delete this grid? So it's simple, just go to edit story and data. Over here, modify the grid system. Select this thing and delete, select this and delete as well. Give OK. Then that's it. Okay, refresh view. OK, you get it done over here. So what it is to be noted over here that this has at least 4 bays, 1, 2, 3, and 4. So we're gonna change it to regular. Before that, we'll delete these columns. Just delete it. So edit story data. Again, modify, added Y. This is gonna be 16. Yes, okay. Okay, then that's it. Your grading is done. Just save the model time to time so that you don't lose data. So let us quickly assign the columns over here. As said earlier, just select 204. Okay, this is gonna be 90 degree. Place it as So it is to be noted that we can't place it over here. Control is it. Place it at the exact grid so as to avoid the n number of warnings and errors that's going to raise. Warnings and errors will actually change the position of the members and also the bending moment diagram and shear force diagram as well. To be frank, the overall behavior of the building is going to be changed unless and otherwise you do perfectly. So defining 200 cross 750, this is going to be placed at all these junctions. Make sure that you are exact to the grid. So it's done over here. So let us draw the walls. Also note that it's gonna be drawing as a pier. I'll let you know what pier and spandrel in the upcoming sessions. So select wall 200. Always ensure that you give the pier label as yes, because when drawing a number of walls, the pier labels are a must. Unless and otherwise we define the pier label, I mean we number the pier labels, the loading of that is not gonna come in the model. So just give it as yes, it's going to be straight line. One thing that's going to help over here is the fixed length and angle. That is 2000. That is our 2 meter, and this has got to be 180 degree. So this has got to be 1200. Enter. Just select over here, and that is right click. You've got it done. Ensure that walls always start from point to point, whereas column strictly lies at the single point. You can see that at this intersection the column is placed, whereas the wall ranges from point to any point in the grid. But ensure that you connect the beam from column to column center. As said earlier, it's very good habit to just save the model periodically. So again, we're going to draw the same wall over here, the same length. And yes, it's done over here now. Just select this option to actually freeze the model from any other options. Just save it. So in case of any doubt, just look at the 3D view of your model. You can actually see that all these columns are in proper way. That is, they grow from the base to the height, and over here the wall is also placed. Always ensure that you have a look at the number of grids over here, I mean the number of stories. So the bottom is gonna be 2 meter in most of the cases. So just change this to ensure that master, so nothing is master unless and otherwise it is gonna be similar to that. Just give okay, okay, that's gonna be there. Save it again.